Module 3, Topic 1, Lesson 1. And we're going to finish out Lesson 3, Lesson 1's activity with our conversation right now. Consider three separate cases for the diagram shown in question 2. Just a reminder, this was question 2. And for each case, determine whether this is enough information to prove that the two triangles are similar. Explain why you think they're similar, or provide a counterexample if you do not think the triangles are in fact similar. Let's talk about this one. Suppose that 4GH equals MH. What that says is that it's going to take 4 of these segments, so 1, 2, 3, 4, to completely match the other side. There's like a 4-to-1 ratio here. Now, the thing is, that's the only information that we're given about how the pair of sides, the corresponding sides, are equal. What we do know is that angle H on both sides, they're vertical angles, so these two angles are congruent. And if I read that right, that's in the remember section on the side of our page 455 notes. The vertical angles are congruent. Specifically for our problem, angle 2 and angle 4, well, that's the angles that are across from each other here inside the triangles. Those are matching, and that's important. We want to have that information. However, that's it. We're not given anything else, and we're not given like a second pair of sides. Like, no, not enough. We need one more 4-to-1 side comparison. The truth is, in order to show that triangles are similar, we have angle-angle similarity. Just find two angles and two other angles that are corresponding, that are the same size. And therefore, you know, because of angle-angle, that the sides, the triangles themselves, are in fact similar. In this case, we have one angle and one side. We need side-angle-side similarity. And we need to know the 4-to-1 ratio exists between the first pair of sides, which is given here, and the second pair of sides. And nothing else tells us that this is 4-to-1 or this is 4-to-1, so we don't know that information. No, it's not enough. Next up, suppose that GK is parallel to MS. And so what we can do is add that notation. I think I'll use maybe this black pen. We can say GK is parallel to KS. And if they go in parallel directions, then that means angle G and angle M are congruent. And I just mentioned it. That means that angle G is congruent to angle M by alternate interior angles. If you don't remember what that is, go look it up. It's a quick Google search, but it also is something we talked about back in Module 2. If the lines are parallel and the angles created by those lines are in fact equal, then they must be congruent. And therefore, the triangles are similar by angle. We have the first angle, that's the vertical angles on the inside, and then we have these two angles being congruent because of that parallel line theorem. Yes, that is enough information to determine the triangles are similar. Angle is the similarity. Let's see here. We have angle G is congruent to angle S, which isn't necessarily evident right away that angle G and angle S are congruent, but we're told that, and because we're told that, we still have alternate interior angles. No, I'm sorry. We have vertical angles right here. We have vertical angles that are congruent, and now this statement, I'll move my paper here in a second, but it says G and S are the same size. That, once again, is angle similarity. Yes, this is enough information, just like part B. Angle similarity shows triangle. Now I got to think of my letters, right? The similarity statement matters. So if I say GHK, and then I use the similarity symbol, if I'm saying G and S are the same, then the similarity statement, G and S, should be in the same location. H is congruent to itself, and then M. And this is a slightly different arrangement of the letters, but it's all based upon what information we're establishing from the very beginning. Yes, that is enough. Some questions to consider. Does knowing 4GH equals HM tell you anything about the ratios of the other sides? Back on this one. No, it doesn't. If we're saying they're similar, it'd be 4 to 1, but we're not saying they're similar. We don't really know. So we have to like base our assessment on what we do know. And what we do know is only that one pair of sides has a 4 to 1 relationship. Another question, is it possible to relocate point S without changing the relationship between GH and HM? Well, no. So this is what they're saying. If you move point S, would that totally change this relation? Actually, it would. It would. This is still 4 to 1. These angles are the same. What if point S was like down here, and then we tried to draw the triangle? No, we couldn't. That angle's the same. You have to still keep that angle. Point S could be like on a line this way. We could put point S down there, and then that would be the triangle, and this triangle would not be the same as the other one. So yeah, point S, you do have to know where point S, or the angle created around point S, is situated. Anyway, thank you for watching this video. That is page 455. We're going to finish lesson 1 video with the talk, page 456. That's next. Thanks for watching this episode, and I'll see you. Don't forget to like, comment, and subscribe, and click forward later.